Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's figure 1, here's figure 2, here's figure 3, and your challenge is to predict the number of leaves, maybe these are fig leaves, in figure 4. If you can do that, can you predict the number in figure 43? And can you write an equation to predict the number of leaves in any figure at all? If you'd like to accept that challenge, pause the video, work it out. Okay, so let's take a look at this one and see if we can make a good guess for figure 4. It doesn't seem to be growing super fast, so my first thought is this is probably a linear pattern. So I think what I'm going to do is just try to find figure 1 in figure 2 and see what's been added. So there are 5 here, so let's just mark off 5. All right, so it looks like we added 3 more. So let me mark off 8 here. So that should be figure 2. Aha, and it looks like 3 more. So if I were going to guess about figure 4, I'd say another leaf here and another 2 leaves out here. And so that'd be 9, 10, 11, 12, 13, 14 for figure 4. So that's my guess for figure 4. But let's look at this pattern. I'm going to put the figure number and the number of leaves. So in figure 1, we have 5. In figure 2, that's 8. In figure 3, that's 11. And in figure 4, we've got, or we're predicting, 14. So let's go ahead and look at the difference between each step. 8 minus 5 is 3. 11 minus 8 is 3. And 14 minus 11 is 3. Aha, so we're getting a constant in our differences. That does mean it's a linear pattern. So our intuition about that was correct. And we can use the equation for a line to model that. So y equals mx plus b, that m, which is the slope of the line, is the rate of growth of our pattern. So that's going to be this difference we found. A difference between each step of 3 means each step it grows by 3 leaves. So we'll put that in for m. So y equals 3 times x. And then the plus b will be whatever we have to add to make this work out with what's up there. So if I tried to put in 1, the figure number for x, this would be y equals 3 times 1. Well, that would only be 3 leaves, and I've got 2 more. So I'm going to have to add 2 to make that work out. So we can add 2 to our equation. So this should be our equation, but let's test it. Let's make double sure. So let's try figure number 2. So I'll put in 2 in place of x. So y equals 3 times 2 plus 2. Well, 3 times 2 is 6 plus 2 is 8. Yeah, that works out. Let's try step 3 or figure 3. Y equals 3 times figure 3 plus 2. So that'd be 9, 10, 11. Yeah, that's what we're getting for figure 3. So our equation is y equals 3x plus 2. Now, to calculate the number of leaves in figure 43, we just have to plug in number 43 for x. So y equals 3 times 43 plus 2. So what is 3 times 43? Well, 3 times 40 would be 120. 3 times 3 would be 9, so 129 plus 2, 131 leaves in figure 43. Well, how did that go for you? Did you predict 14 in figure 4? Did you find an equation that looks like this? Let me know. Thanks, everybody.